So I can introduce Stuart and Pin from Climax, UK big studio coming from Portsmouth. And Stuart will introduce Climax. I remember that Climax is our sponsor of Svilupparty, so thank you. Un applauso a Climax! Okay, and Pin will explain us the PC porting of Returnal. Returnal, you know, is a super beautiful game for PS5, and Pin managed the porting to PC, encountering a lot of specific things that very interesting to understand. Just to have, just to understand how what does it means to work in this environment at this level. So, please.
Hi, thank you, Ivan. Hi, guys. First of all, apologies. Our Italian is very terrible, so we're going to speak in English. It's a lot better. My name's Stu. I run all our recruitment. This is Ben. He's our development director. We're just going to show you our show reel. Then I'm going to hand over to Ben. He's going to give you a technical talk on Returnal.
Thank you very much. Hello? Was that okay? As Stu said, my name is Ben Potton, and I'm the Development Director at Climax Studios. And today I would like to talk a bit about our experience working on Returnal, and particularly porting Returnal to the PC from PlayStation. So I'm going to get a little bit technical, but hopefully give some guidance of things to avoid when you're working with Unreal on the PC, and how to avoid some of the mistakes that a lot of games make. Or as I like to call it, why PC ports mostly suck. Yep. Like that? Better? Cool. So I'll give you a brief overview of Climax Studios. So we were founded about 37 years ago. We're based in Portsmouth in the UK, right on the coast there. That's our office. We're currently about 170 people, and we were an independent studio for 35 years of our life, and then a couple of years ago we were purchased by Keywords, so we've become part of the Keywords family. And we're known for console development, PC development, and we've also done a lot of VR and AR and other technologies. These are some of the games that we've worked on over the years. And also we do full game development, we do co-development with other studios, and porting. So let me give you an overview of Returnal if you've not played it. So it's a third-person roguelike shooter. Housemarque, the Finnish developer, were the lead developer on the title. It was published by Sony. It's one of the first PlayStation 5 titles that they released. And we were involved in a co-development role on the original title. It was also multi-award winning. It won several Games of the Year awards. It won 2 BAFTAs, loads of awards. And most importantly, it's rock hard. If you like really tough bullet hell shooters, then this is a game for you. We'll be over there later. You can come and play it. So this is kind of how it started for us working on Returnal. Initially, I had a very cold trip to Helsinki. And we had a very small technical team to begin with, working with Housemarque. And we were implementing mainly the multiplayer and the kind of cooperative gameplay systems. But over the course of the next 2 years, that grew to 50 people, all disciplines. And then we worked for the next 2 years to the release of the PS5 version. So during those 2 years, we touched level design, we touched concept art, we made characters and enemies from beginning to scratch. We touched nearly all of the code systems in the game. So we really had a quite key development role in the title. So then it brings it on to the decision to port the game to the PC. So obviously Returnal was hugely successful on the PlayStation 5, and Sony wanted to take advantage of that success. And they had a new strategy of porting their PlayStation 5 exclusive titles to PC. Normally, a couple of years after the PS5 version was released, they'd release a PC version. And obviously, in this case, Climax were the obvious choice to make that port. We had a deep understanding of the game, we worked with the code, we knew the data pipelines, and we've also got a really long history of doing quality ports. So the important thing is, how did it go? And these are some quotes that I picked off Metacritic. So this PlayStation 5 hit is a masterclass in porting a console game to PC. Why this sci-fi masterpiece rocks on PC. It really went very well indeed. I think it's one of the strongest ports out there. The Metacritic score is on par with the original game, which is almost unheard of on the PC ports. So overall, everyone has felt it was a really huge success. But you know, if you're a PC gamer, and I'm sure some of you are, it doesn't always happen like this. So here are some other quotes from other PC games that I won't mention. Plagued by issues across the board, whether it's stuttering frame rate, instability, crashes, popping, or visual glitching. This is one of my favorites. Last year was a disaster for PC games. Here's how things need to change. So I'm going to kind of give an overview of how to avoid getting a review like this if you're releasing a PC game. So, an overview of porting from PlayStation 5. It's an Unreal Engine game. It's going to be easy, right? You just select PC platform, you click build, it's done. Well, not quite. So to begin with, you've got a lot of issues with Unreal Engine to begin with. First of all, as you probably know, it comes with full source code, which developers absolutely love. But it does mean developers can change the engine quite a bit. And Housemarque did this. They really went to town on this engine source code. They put in their own global custom illumination system, so they completely rewrote the lighting in Unreal Engine. Also, they wrote their own bespoke particle effect system, which was really key to how the game looks and really key to the gameplay as well. You can see an example of it working there. And while they had kind of prototype versions of this working on the PC, it wasn't designed to be scalable at all. It wasn't designed to be optimized. So really, all of this we had to re-implement for the PC. Also, you've got the general hardware issues of moving from a console to a PC. A PlayStation 5 is a fixed platform, so you know exactly what hardware everyone's going to be playing the game on. PCs vary massively, so it could be a very low-end PC, it could be a very high-end PC. And obviously, Sony want to push this to the lowest minimum spec possible. So the more people that they can sell their game to, and the more people with PCs that can run it, the more money they make. Also, the PlayStation 5 has some really advanced custom technology in there. It's got an extremely fast SSD architecture. It's got a custom operating system to get the most out of all the hardware. It's got a 3D audio processing chip, so loads of stuff you can't necessarily recreate on PC. And finally, this is a really important one. PC gamers are a kind of different breed to console gamers. So for a console gamer, it's about sitting down in front of the TV, playing the game, having a great experience. For a PC gamer, quite often it's about showing off their rig, running the game at the highest resolution they can, running it at crazy frame rates, turning on ray tracing, all of the bells and whistles, and really trying to break their system with your game. So you have to take that into account. So to begin with, you've got to think about getting the basics right. Obviously, your minimum and maximum specifications, CPU, GPU memory requirements, resolution. This is an interesting one for PC because you can get all kinds of crazy monitors out there. You can get ultra widescreen monitors, and for a PlayStation 5 game, it's probably not designed to work on those. You need to decide on the minimum frame rate for your game and the maximum frame rate. So for us, for Returnal, it's an action game. We insisted that the minimum frame rate was going to be 60 frames a second. If you want to hit the minimum spec, you have to hit that frame rate. And also, you tend to find if a game is being designed to run at a specific frame rate, if you go much lower or much higher, you might get gameplay or physics issues. And finally, keyboard and mouse support. That's kind of given for a PC game. You've got to decide on what extra features to add. So a benchmark mode, for instance, lots of PC games have them. We added one, and I'll talk a little bit about that later. And also, you have all the custom tech from NVIDIA, from AMD, like ray tracing, DLSS, all those kind of extra features that you want to include. Finally, you've got other considerations. There's cross-play. Do you want to let your PC gamers play with PlayStation 5 gamers? Do you want to let people who bought it on Steam play with Epic Store gamers? In our case, we decided not to let PC gamers play with PlayStation 5, but there was cross-play across the PC stores. And then, as a last kind of note, DLC. Most PC ports are going to include all the DLC, so you need to think about porting that too. So this is where I'm going to get a little bit technical, but this does apply to anyone who's doing an Unreal Engine game on PC. So if you've looked at any reviews of PC games, or you've been on Reddit, they always talk about shader caches. So I'm going to give an overview of what they are and why they're important. So basically, they're just pre-compiled bundles of shader code that's used by your game. So why do we need them? Shaders are written in a high-level language, so they need to be compiled for basically every bit of graphics hardware they're run on. They need to be created for every material in the game, and they're going to be unique to every graphics card model, whatever user settings you've set, and sometimes they're even unique to the driver version that you're running. So there's many, many more permutations than on a PlayStation console. You can't just include the shader cache to the end user because it's going to be different for every person who's playing your game. And obviously, without a cache, the shader is going to get compiled at runtime, and that's going to cause a hitch, a stutter in your game, and that's what a lot of reviewers complain about when they're playing the game for the first time. So in Unreal Engine 4 or Unreal Engine 5, it's quite similar. This is how they kind of work. You have two stages, PSO data and PSO shader cache. So PSO stands for Pipeline State Object, and it's basically a description of everything your graphics card is doing at a particular moment in time, how it's set up, what shader it's running, and there's one of those for every material. So during development, a tester will play your game, and when they encounter a new material, the state of the pipeline is recorded and it's stored in the pipeline state object data. Then during release, the PSO cache is generated at runtime, normally at the start. So you may have a little loading bar as it generates the shaders. And all of the list of shaders comes from the pre-collected PSO data. And as I said, if you miss one from that list, you're going to get a hitch in gameplay. So this is how you make them. First of all, you turn on PSO caching in Unreal Engine. And then you have to get your testers to encounter everything in the game. So basically, every enemy, every part of the level, every weapon, every kind of combination of situations that might make a new material. And they have to do it with every graphical setting that your game offers. So if there's different detail settings, different LODs, they've got to go through all of that. And they need to redo it every time you change content. So this is really a massive amount of work. So you don't need to hit 100% coverage, but you need to get pretty high. I think we reached about 98% coverage of the shaders used in the game, which is what you really want to be aiming for. And it probably goes without saying that procedurally generated content games, like a sci-fi rogue shooter, make this very difficult, because every time you play the game, you're going to get a different run, you're going to get different enemies, so you have to keep replaying it. But it's not all about shader caches. No matter what Reddit says, there are other ways your PC game can suck. So here's a quick example of how a better hardware can result in a worse game for your end user. So here's an example game running at 60 frames a second. As you can see, the GPU's got loads of free time. The CPU's got loads of free time. Everything's great. Rock solid frame rate. And then the user buys a new graphics card. He puts a 4090 in. He wants to run the game at 120 frames a second. So this basically means that you now have half the amount of time to do everything your game needs to do. Not just the graphics, but all of the physics, all of the CPU, all of the other things that you need to do. And in this example here, you can see we've gone over the frame. That's going to cause a one-frame hitch, and they're going to go onto Reddit and complain about your game. So the kind of takeaway of this is a faster frame rate means you have less time to do everything else in your game. And you're always going to be as slow as whatever the bottleneck is in your game. If it's CPU, that's going to cause you the issues. And another thing that's really important about CPU is it tends to be more spiky than GPU. So you might go to a really hectic part of the level and the GPU goes up or down, whereas CPU load comes in little chunks. So it might be you go somewhere new, you're loading in new shaders, you're loading in new audio, and you'll get these little jumps that make you drop a frame, maybe 2 frames, and that's where it gets really bad for the end player. Also, you have all these different systems that can have kind of bottlenecks, and it's really hard to predict what's going to go wrong. And any intermittent drop frames are described as micro stutters, and it really makes PC gamers angry. So the way we dealt with this is we carefully analysed each system on its own, optimised it. We did a lot of work on loading and unloading objects, so that was much more optimal than the original version. So we could run at 120 frames a second quite comfortably. So you have some other hardware considerations. As I mentioned, the PlayStation has an ultra-fast SSD, so really, really quick. Returnal used this really heavily for streaming. They streamed in all of their audio, they streamed in level chunks, and it's quite hard to match that on PC, so we had to do a lot of work here to try and make it faster. We compressed all of the data, we did loads of other tricks to try to get around this. And obviously the controller, the PlayStation 5 controller is excellent. It's got really clever haptic feedback on the triggers and everything. This was very heavily tied into gameplay, so we had to redesign how the controls work, make sure it was still possible to play it and fun to play it on a PC. So some other areas you have to consider. User interface. So as I mentioned earlier, PC gamers have really weird monitors. Sometimes they have ultra-wide monitors. And when you take one of the standard UI screens, you put it on an ultra-wide monitor, it usually looks something like that, which is not particularly good. So a lot of the work we had to do was going through every screen, every bit of UI in the game, reworking it so it was viewable and usable on a widescreen monitor. Obviously, you've got all the controller screens that you expect on the PC, keyboard and mouse rebinding, and all of the thousands of settings that you expect on a PC game, all the graphical settings. We had to do all the UI for that. So I mentioned this earlier as well. NVIDIA, AMD, Intel, they all provide these amazing libraries that can really boost performance of your game. And that, not necessarily related to it being a port, but any PC game, you can get massive quality and performance increases by integrating these libraries. And they do all the work for you. But the issue is they don't work out of the box, so you need to do some work yourself to try and make them work with your game. They're usually created for a specific version of Unreal, for instance. Usually 0.5 of a version after what you're using. So you might have to backport it to your version of Unreal. And when you turn them on, they quite often cause visual issues. They might cause artifacts on your screen. And you have to work with NVIDIA to try and work out what these are. So NVIDIA don't actually write games, they write text. So they don't know what it's going to do when you turn it on your game. And also they can cause render crashes. We had quite a few of those related to the particle system, so we had to go and debug those. One additional feature we added was the benchmark. And we took the approach of making a complete bespoke level, and we wanted it to recreate gameplay as much as possible. So we used dummy enemies, we went through all of the AI logic systems, we triggered particles the same way that the game did. So we didn't want it just to be a cutscene, because that doesn't really test your hardware. We also provide quite extensive statistics, so you can see exactly what part of your system is being stressed. But even then, you can't recreate every aspect of your game with a benchmark. But I think we did a pretty good job of it. So here's an example of the benchmark results screen. If you want to come and see it a bit more closely, you can check it out over there when we're a bit later on. But basically, we give you a breakdown of every aspect of the benchmark, what parts of your system were being stressed, and loads of data about how best to tweak the game for your system. So a few other things that you need to think about. Obviously, platform, networking. You've got to do a little bit of support for Epic Store. You've got to do a little bit of support for Steam Store. Also, if you're doing networking, you've got to implement Epic networking, Steam networking, and handle how you're going to do cross-play. Now, the way we did this was to use the Epic online systems, which are absolutely brilliant. They handle it all for you. They do cross-play. They tie together all the different network systems. And one thing we didn't anticipate was this really annoyed Steam store users. So for some reason, they hate Epic. They hate seeing something coming up on their screen saying, we're installing Epic Online Services. There was a massive backlash, but even though you should use it, it's brilliant. And one thing we had to do was, the original game used, or I would say abused, the PlayStation network functionality to add lots of features. So a lot of the networking features were only would work on the PlayStation network. So we had to work with Sony Online Tools Group, and they made a custom backend for us as well. So sometimes you need extra servers to try and get all the functionality you need. And obviously, there's minor things like achievements, controller support that we've talked about before. So, as I said, it went extremely well. We got really good reviews, but we did miss some stuff. So, even with all that work, we still had some stutters for some people. And, you know, they were very loud on the internet. They did their Reddit posts. They did their Steam reviews. It's really gutting. One thing we did miss, I mean, it's hard to avoid, but Unreal Engine 4 doesn't pre-cache ray tracing shaders. And it's kind of the same in Unreal Engine 5 as well. So if you're playing the game with ray tracing, you're still going to get some stutters. We did port some code from Unreal Engine 5 back to Unreal Engine 4, which helped a little bit, but there are still going to be issues. This is kind of a weird one because we could never recreate it, but for some people, the shader precompile failed. Rather embarrassingly, it failed for Digital Foundry while they were writing their review, which was quite bad. But luckily, they kind of reached out to us before they put the review out. They said, should this happen? We said no. We had a chance to fix it, patch it. We put a recompile option in, and it didn't affect the end review, so that was really fortunate. One thing we didn't expect to do was to have to fix PlayStation 5 bugs. The testers found them, and they sent them to us. Reviewers found them and complained about them. So you might think if you're doing a port, it's not your job to fix the original game, but you have to do it sometimes. And we had a couple of fatal error crashes, which are obviously really bad. Again, they were very, very rare. We couldn't recreate them on our machines, but if you put your game out to hundreds of thousands of people, someone's going to find them. So we had to kind of patch them the best we could after release. And this is kind of a weird one as well. On the PC, some people don't play the games just from how they feel. They'll put frame rate graphs up, they will analyze it, and if there's a drop in frames, they're going to complain, and it doesn't make them very happy. So this was something we kind of weren't expecting. So to give you an overview, how much work is it to take a PlayStation 5 game to PC and get the kind of reviews that we did? So it took us 2 years to do from the end of the PlayStation 5 version. We had 30 people on the team at peak, and this is a kind of breakdown of the team. So obviously mainly coders. It was very technically challenging. We had some artists doing effects rework, level rework, and UI. We had quite a big internal QA team. They were generating PSO data. They were testing the systems. They were running on different types of hardware. And then a little bit of design, a little bit of audio, and some production coverage. So probably quite a lot of work, probably more than you were expecting. So I guess the key takeaways are, why do PC ports usually suck? First one, not enough testing, not enough PSO coverage. Your key issues are not showing up on your dev PCs because you're running the game every day, your shader's always compiled, you're probably running on quite normal hardware. So you really need to get a good test team to test it on as much hardware as possible, get as much coverage. not thinking like a member of the PC master race. So I say this as a PC gamer myself, but PC gamers, as I said, they have ridiculous resolutions, stupid hardware, really high frame rates, super widescreen. If there's something weird they can do, they will do it. I think one of my favorite bugs was someone was running the game in super widescreen monitor, but they were playing it vertical. And they raised a bug saying it doesn't work. And my response is, what the hell are you doing? Why? So this is quite key, not putting enough good people on it. So a port is not an easy job. Technically, it's quite often more challenging than doing an original game, so you really need to have your top people on it. As I mentioned about the NVIDIA and AMD support, not engaging with them early enough. Really, you need to get them on board as soon as possible. They will benchmark your game, they will profile it, they will give you suggestions about making it faster, they will help you fix bugs. They do all this kind of stuff for you if you get in contact with them early enough. So make sure you reach out to them. And likewise, not engaging with reviewers early enough. So as I mentioned, we had a really good relationship with Digital Foundry that helped us circumvent some of the issues that might have come out if we didn't have that relationship. So they contacted us directly and we could fix issues on day one. And the key takeaway, the most important thing is not spending enough time, effort and money. So it really is not a cheap thing to put a game to PC. If you want the kind of quality and the kind of reviews that we managed to achieve, you really need to spend a lot of money on it. So I'm just going to leave you with one final quote that we've had. Developer Climax Studios has hit it out of the park with this port. And this made me really happy. This is basically, as a developer, what you're aiming for. Great reviews, happy people, and a really quality product. Thank you very much. Do we have time for questions? Or one or two questions, if anyone's got any? No? No, one. Yeah.
Did you have support from the original team that developed the Returnal doing porting to PC?
Did we have support from the original team? Well, yeah, so we worked on the original Returnal, so we had people in the studio who knew all the systems anyway. And we also had constant discussion with Housemarque as well. So we could, if there was a bit of code that we hadn't used before, we could reach out to them. They weren't great at writing documentation, so we still had to figure out a lot ourselves. But yeah, they were there if we needed to ask them anything. Cool. And one more question. Yep.
I saw you had like a game from Deep Silver as well.
Yeah.
Did you co-development on that one?
No. Yeah. So we worked on a game for Deep Silver. That was, I can't remember which one it was, but that was a complete full development from beginning to end. So we do less of that now. We tend to do more AAA, but previously we've done a lot more full games, and that was one of those. Cool. Yeah.
Okay, big hand for Ben. Fantastic. We will be in the corner, or if we're not at the corner, we will definitely be at the bar.